All right. Welcome back to another free webinar on conducting IRB review of AI in human subject research. I am the founder and principal consultant of TechInHSR. It's a consulting practice built specifically around helping research institutions and researchers develop the capacity to review and oversee this AI research. So what we're going to do today is walk through a case study together, completely fictitious, but it's something that we're actually seeing quite a lot of. So I'm going to call this AI protocol NeuroScreen. By the time we're done, you'll have a practical 4 checkpoint framework that you can apply to any AI protocol that lands on your desk. No coding background required. So let's dig into it. Before we get to the case study, I want to set the stage with the core problem. So IRBs right now are caught between two failure modes when it comes to AI protocols, and both of them are going to cause real harm, not just to the participants, but to the institution. The first kind of failure mode is under protection. So the reviewer might look at a protocol, see AI, think software, and then, oh, it's just software, no needle, no drug, no physical intervention, so the review is perfunctory, maybe. The result is that we miss algorithmic bias, we miss privacy risk, we miss specific and often invisible harms that AI creates when it fails. And then the second failure mode is overprotection. So the full board might review for everything within any AI component, regardless of risk level or applicability. And so that's going to create bottlenecks that stall legitimate innovation and burns IRB resources on low risk work that doesn't need that level of scrutiny. So the solution is not picking one of these two options. The solution is going to be this dynamic framework, one that matches this level of oversight to the actual risks of that specific moment in that algorithm's life cycle. And that's what we're going to be building today. And so I want to underline one thing, and that's we can no longer treat AI like a simple calculator because a calculator does not learn. It doesn't drift. It doesn't fail in ways that are invisible to people using it. But AI does all of those things. And that's going to change the oversight calculus entirely. So, case study. Let's meet NeuroScreen. NeuroScreen is an AI-powered neurological screening tool designed to detect early indicators of cognitive decline. So think like early Alzheimer's and related conditions through passive ambient monitoring. And then the target population is elderly patients recruited through memory care clinics. Now, how does this work? The app runs continuously in the background on participants' personal smartphones and tablets, and it's going to capture two streams of data. One is it's going to capture this ambient audio, meaning that it's recording background voices and sounds in the home. And so the other one is keystroke biometrics, meaning that it's logging the rhythm, the pressure, and timing of every tap and swipe on that participant's phone, whatever they're doing on their device. And then the AI is going to analyze these behavioral and acoustic patterns over time to generate neurological risk scores and then triage alerts, which are then sent to their telehealth provider who will make care recommendations. So on the surface, this sounds innovative, but let's run through the 4 points to check and see what we actually find. So here's the framework, 4 checkpoints. We're going to work through it in sequence. So checkpoint one, what are we dealing with actually? What kind of software is this? Is it traditional rule-based system? For example, like the way a recipe works, or is it machine learning system that's inferring rules from the data? In other words, we call it like the learner. We're going to go over this in the next slide. But this distinction actually helps us put the AI risks into perspective. And then checkpoint two, think Belmont 2.0. So how do the foundational ethic principles that the IRB all know and love, respect for persons, beneficence, and justice, how do they actually apply in an algorithmic context? So these principles still hold, but sometimes we just need a little help translating how AI research fits within those ethical principles. And then checkpoint three, 45 CFR 46111, which is IRB approval criteria. So think risk minimization, equitable selection, data safety monitoring, privacy, confidentiality, and consent. So all of these have AI specific dimensions that traditional reviewer checklists just don't capture. And then the last checkpoint is just FDA considerations. So, is this a device software function or a software medical device? What regulatory pathways might apply? And critically, does the sponsor's own risk classification hold up? Right? That's something that the IRB gets to decide. Okay, so let's go ahead and jump in. The first question any reviewer needs to answer is what kind of AI am I actually looking at? So I use two categories. I call them simply the recipe and the learner. A recipe is like this traditional software where humans write the rules. If A, then B. It's transparent, predictable, and traceable. If it fails, you can find exactly where in the code that it went wrong. A learner, the one on the right, is fundamentally different. The system infers its own rules by processing enormous amounts of training data. Nobody wrote the specific logic it's using. That machine actually did it on its own. So the outputs are statistical and probabilistic, and it's opaque, meaning you cannot open the model and then read out the rules it learned the way that you could read source code. So NeuroScreen, our case study, is unambiguously this one on the right, the learner. So it's analyzing thousands of microbehavioral signals, keystroke timing, audio patterns, speech rhythms to generate neurological risk scores. There's no human that wrote the rules for what specific combinations of keystrokes patterns that predicts this cognitive decline. The model learned that from their training data. So why does this matter? It's because that left type, right, traditional software, that can fail predictably. Um, but on the right, the learner, that can fail in ways that nobody anticipated, in ways that are invisible at the point of failure, and in ways that are systematically worse for specific subgroups. It's not to say that we can't do anything about that, but that is just typically what happens. So that's a categorically different risk profile, and it requires a categorically different approach to our review. So in general protocol review, right, if they use any of the following language like AI-driven, machine learning, predictive model, or neural network, or trained on data, then you're probably looking at this type of AI on the right, which is the learner. And the review has to reflect that, right, because it introduces unique risks. So here's a dynamic that shows up consistently in AI protocols, a genuine disconnect between what the researcher believes their tool is doing and what it's actually doing. So the researcher's intent with NeuroScreen is legitimate. They want to find early biomarkers of neurological decline using passive, non-invasive monitoring. And they're not trying to harm anyone. They believe what they're building is a helpful tool. But the AI reality is different in several important ways. First, the system is capturing far more data than intended. Continuous ambient audio recordings in someone's home is capturing their household members, visitors, private conversations. People have no idea they're being recorded and who never maybe even consented to any of this. And so that's this surveillance footprint that extends well beyond the enrolled participant and may sometimes have state law implications. And then second, the models be biomarkers, they're used as proxies. Basically, they're used as these statistical correlations in the training data, which means they're not validated clinical markers. The researcher might genuinely believe that these patterns are meaningful, but without a validation study in that target population, there's really no evidence that actually it can predict what the model claims it's predicting. And then the researcher intends the tool to assist clinical judgment, but when a telehealth provider receives an AI-generated neurological risk score or triage alert, the practical effect is that the AI is driving this clinical decision. It could be designed otherwise, but in the current scenario, it's driving it. The question of whether the human is meaningfully overseeing the AI, looking at the output and the justification for that output, the data used for that output, or are they just rubber stamping it? Right? That's a real question. And the NeuroScreens protocol doesn't actually address that accurately. So let's look at checkpoint three. That's the 111 criteria, the IRB approval criteria. I'm going to start with the consent because NeuroScreens has a specific and egregious problem. The consent form described NeuroScreen AI as this basic analytic tool. Originally, that's how it came in this hypothetical scenario. And the framing is doing work, right? It's designed to minimize the subject's perception of what the AI is actually doing. An analytical tool sounds more like a spreadsheet. NeuroScreen is actually running acoustic surveillance of somebody's home. But here's the specific contradiction that should stop any reviewer and cause pause, right? The consent form stated that the app will not be used to make medical decisions. And then in the same document, it notes that telehealth providers will make neurological triage and care plan decisions based directly on the AI alerts and output. So these two statements cannot both be true, and participants cannot meaningfully consent to a study when the consent form contradicts itself about the fundamental nature of the intervention. Under Belmont Report's ethical principles, subjects have the right to know if they're interacting with AI, if AI is being used in their care, and if AI has these like known limitations, and what happens to their data. And none of these things were adequately addressed in the NeuroScreen's consent form. So, any consent form for an AI study that describes the AI as merely like an analytical tool or underplays what it actually does, or claims it's like a support system or a decision aid, without explaining like that its diagnostic accuracy actually is the investigational focus of the study, and without disclosing its known limitations, means that we're not being fully transparent, so we'll have to send it back for revisions. Also, I would like to note, so for elderly participants with possible early cognitive decline, the adequacy of consent question is always going to be an issue, right? The IRB needs to assess whether that population can meaningfully process what they're consenting to, and whether the protocol includes appropriate safeguards for that vulnerable population. So, for example, are they going to understand complex risks of like, what does it mean to store my data in the cloud? And what does it mean that this data will be processed by a third party for research? And so that's all part of fully informed consent. Still checkpoint three, right? NeuroScreen has three specific data and privacy problems, and we're going to walk through each of those. So the first problem was that cloud vulnerability, right? The protocol states that ambient audio, so right, that continuous background voice recording from inside the participant's home, and exact keystroke biometrics are going to be stored on a HIPAA compliant cloud. Now, citing a major tech company as the cloud provider without a finalized BAA or business associate agreement or a third-party security audit is a material privacy risk. The IRB should not accept this general reference to a cloud vendor as evidence of HIPAA compliance. That's just not how it works. And that's usually why your third-party risk management or your IT and security services are going to have to evaluate that separately, but it still should be done. And also, we need to be very specific about what that data actually is, right? Even if you take names out or direct identifiers, we're talking about continuous voice recordings made inside elderly people's homes, right? Capturing household members, visitors, and those intimate domestic like life conversations. And plus, we're getting those granular behavioral biometrics. So if that data is breached, the re-identification risk is very real. Also, just by nature, large data sets make true anonymization pretty much impossible. Second, the decommissioning gap. What is that? The protocol says nothing about what happens to any of this data at the end of the study. Will the continuous listening app be deleted from the participants' personal phones? Will it stop recording? How do we ensure that it's no longer recording them? What process ensures that? What happens to the commercial AI model that was trained on their intimate identifiable home audio? So these are risks that have to be articulated in that protocol. And third, future use and commercialization. So NeuroScreen, in its nature, is a commercial product. right? Participants' data is training a model that has commercial value. The consent form does not disclose this. Under Belmont Report, the future use and commercialization of participant data is something that subjects have a right to understand before they consent. So one thing that I would look out for when reviewing these studies is vague data collection language, like we may include this data, or we could collect this data, or we'll consider collecting that data. That is not acceptable in an IRB protocol. If the researcher doesn't know exactly what data they're going to be collecting, then they should not be getting that data without that informed consent. And then checkpoint 3 still, this is one of the most consequential issues in NeuroScreen submission, and it's the kind of thing that you would find when you do your homework outside of the four corners of a protocol document. That the core principle here is that we cannot objectively validate a tool when your financial success depends on its performance success. So that's not a judgment call. It's really just the structural problem that compromises the scientific validity of the entire study, right? FDA has requirements about it, NIH has requirements about it. In general, Common Rule has requirements about it. In NeuroScreen's case, right, the IRB reviewer did a quick internet search and found publicly available records revealing that the PI actually has a direct financial interest in the commercial deployment of NeuroScreen. The protocol didn't disclose this, the consent form didn't disclose this, and there was no conflict of interest management plan because it wasn't disclosed. So the IRB is being asked, essentially without this knowledge, to approve a non-inferiority randomized clinical trial, a validation study where the person evaluating the tool's performance has a financial stake in the outcome. So the required actions are pretty straightforward, right? Under 21 CFR 54, financial disclosure requirements of clinical investigators, 45 CFR 46, and depending on your funding institution, right? The IRB has to require full disclosure, a formal COI management plan, and explicit relationship disclosure in the consent forms. And then just a quick note on workflows, right? Reviewing publicly available records and the product company website or even the product brochure, that is not out of scope for the IRB. In fact, it is necessary for the IRB in order to conduct a thorough review of that AI protocol, especially if the study team did not provide this information within their submission. And now we're going to talk about checkpoint 4, the FDA considerations. So checkpoint 4 is basically like software as a medical device or software device software functions, right? And that's going to run parallel to your human subjects determination, meaning is this human subjects research and does the IRB review it or not, right? These are independent analyses, but both apply to NeuroScreen. So the key question is this software intended to treat, diagnose, mitigate, prevent, or drive clinical care? And does its output influence clinical decision making? Now, this is not, is that doing it in this study? It's the intended use of the tool as it's designed, right? So for NeuroScreen, yes, on both counts. The tool generates neurological risk scores and triage efforts that directly inform telehealth providers' care plan decisions. The fact that a clinician is technically in the loop is not going to change the analysis. The clinician cannot independently interpret thousands of raw keystrokes and data points and audio waveforms to make that decision, right? So the AI is doing that clinical reasoning and the clinician is just reviewing the score. And at least that's how it's currently designed. It can be designed otherwise so that it can be more transparent, but in this case, it was not. So that means that NeuroScreen is not a general wellness tool. It is not a communication technology. It is software as a medical device subject to 21 CFR 812 and therefore subject to that investigational device exemption regulations. Or it could be abbreviated IDEs depending on various scenarios. So the intended use statement is going to be everything in FDA regulations or considerations. It defines what the product does, for whom, and in what setting. It's going to control labeling requirements, determines medical device status, it's going to set risk class, and it determines what clinical evidence is actually required in this study before the study can proceed. So if the protocol's intended use statement is vague or understates what the AI actually does, which is what we saw in NeuroScreen protocol, then that's going to be a problem the IRB needs to address before we move on to approval. Okay, so once you've established that you have a medical device, then you need to determine the risk level of that device, not the study risk level, but the device risk, right? So this is important because the regulatory pathway and the IRB's role in that depends on whether the device is classified as significant risk or non-significant risk. So, non-significant risk devices require an IRB determination, but do not require an FDA submission. Significant risk devices, on the other hand, are going to require a full FDA investigational device exemption application and full board review. Sponsors do have a financial incentive to classify their risks, the risks of their devices as non-significant risk, but the IRB should be independently evaluating that. If the FDA jumps in and has a say, then ultimately they're the final say. But if not, then the IRB is the final say on that. So let's apply the significant risk criteria to NeuroScreen. Does it present potential for serious risk to health, safety, and welfare? And we're talking about the information that we have, right? We might not have all that information, but based on the information we're provided, does it present that potential risk? Yes. In this case, yes, because misdiagnosis of early neurological conditions in elderly patients has direct consequences for treatment decisions and care planning. Is its intended use for use in a population that is inherently vulnerable? Yes, elderly patients with possible cognitive decline. Does its output drive clinical decisions without the clinician being able to independently verify the underlying analysis? Yes, that's actually the main criteria for significant risk, but the first two are just things to think about in terms of risk to participant. There are other categories, obviously, but in terms of this one specifically, those are the things that jumped out to me. So with that information, even if a sponsor classified their tool as NSR, the IRB really has to think about that and determine if the information that they were provided has enough evidence to support that determination. So, for example, there's a lot of potential to change the way the tool functions and change its intended use so that the tool can be changed from SR to NSR, non-significant risk. There are also ways to reduce the study from greater than minimal risk to minimal risk if certain guardrails are put into place. And I'd actually take the time to actually recommend that to the study team. All right, it's coming off as significant risk, but if you do A, B, C, we could bring it down to non-significant risk and or minimal risk instead of greater than minimal risk. But again, the current protocol as it is did not have any of that. So at face value, it starts feeling a little bit like significant risk. So ultimately, the IRB plays an independent role in this device risk classification, and a sponsor's NSR determination is not binding on the IRB. If the IRB disagrees with the sponsor's classification, then you're going to have to require the sponsor to seek either an FDA IDE before the study proceeds or consider reworking the protocol and the device intended use and function as well. So pulling all of this together across the four key pillars of the NeuroScreens protocol, here's what the sponsor claims versus a thorough review of what it actually reveals. On clinical evidence, right, the protocol implies a validated study design testing a reliable diagnostic tool. In reality, there was no foundational analytical validation. The AI had never been tested for accuracy in any controlled non-interventional setting. The study is attempting a powered, non-inferiority randomized control trial without any prerequisite evidence base. And on data and privacy, the next box, the protocol claims secure HIPAA compliant data handling, but in reality, the protocol had no verified BAA, no decommissioning plan, vague data collection scope, and intimate home audio being processed by a commercial AI with no disclosed future use restrictions. The next box on independence and integrity, the protocol implies objective scientific evaluation, but in reality, we saw undisclosed financial conflicts of interest with no management plan. And then the last box on the regulatory pathway. So the protocol implied it was just simple software in a supportive role, but in reality, the way it was written, the way it was presented to the IRB, an investigational software as a medical device with significant risk characteristics that might require IDE consideration. Again, that's what was provided. It might be different, but we needed that documentation to support those claims if it truly was non-significant risk or if it truly was clinical decision support instead of what it was written out to be. So across all these pillars, right, the claim doesn't match the reality. And this is not an approvable protocol as submitted. So we would want to send it back for some clarifications and revisions. So how should AI research be structured? Let me show you the framework that I've developed with my colleagues. It's called the three-stage AI HSR review framework, AI Human Subjects Research Review Framework, because understanding it is what makes the neural screen failure so clear. Stage one is discovery and ideation. So this is the training phase. The team or the sponsor is building and refining the model on retrospective secondary use data or maybe even synthetic data. There's no real-time participant interaction. The risk is pretty minimal if the data is handled securely. And IRB review is usually expedited. Stage two, we take everything that we did in stage one, but this is validation in shadow mode or simulation or simulated environments. So this is the most critical phase and one of the most often skipped. The algorithm runs in parallel with actual clinical activity. It's seeing real data, generating real outputs, but those outputs have no effect on the real world decisions. No one is acting on them. No one is seeing them and then acting on them because that influences their decision making. The purpose is to establish this baseline performance, right? Does the algorithm function accurately in the actual target population under real world conditions? So in this case, the risk is moderate. Full board IRB review might be needed because we want to give attention to is it a device or not. We also want to pay attention to scientific validity and privacy. And that device determination usually happens under the full board anyway, but it is possible that we could bump it back down to an expedited review if the study is minimal risk and the device is determined non-significant risk. Stage three, we take everything that we did from stage one, stage two, all of that data that supports us moving into the final stage, stage three, real world intervention. So the AI is now influencing actual patient care decisions. And this is where the risk is highest. Full board review is typically required. And the critical prerequisite is, right, that stage two was completed and the results support that proceeding forward. So the logic here is really proportionality. Different oversight for different risk levels. And the sequencing really matters. You cannot skip from stage one to stage three because stage three legitimacy depends on stage two having been done. And so here is exactly where that NeuroScreen protocol failed. The NeuroScreen acoustic and behavioral AI has never been analytically validated for diagnostic accuracy in a controlled non-interventional setting. Now, it might have been, but that was not the information that we were provided. So we need to see if there was that information that just was inadvertently missed from the application. But there was no stage two in the protocol's history that we knew of. The reference list contains 0 peer-reviewed validation studies, demonstrating this AI's accuracy in any population, let alone in elderly patients with cognitive decline. Yet the protocol was attempting a powered, non-inferiority, randomized control clinical trial, stage 3, that directly altered that patient's care and generates real plan decisions based on that opaque output of an unvalidated tool. So they just jumped straight from ideation to intervention, skipping that most important phase entirely. So the principle is simple. You cannot prove non-inferiority against a human physician if you haven't yet proven that the algorithm functions accurately in a controlled setting. So the study is premature. So under 45 CFR 46111, right, approval criteria, testing an unvalidated AI on a vulnerable population, elderly individual with positive cognitive decline without foundational accuracy data creates this unacceptable risk of harm and compromises that scientific validity or sound research design. And so that was the limitation of this study. Again, the absence of stage 2 validation study is by itself a disqualifying deficiency for any AI protocol that proposed real world clinical use. And so here we would just ask them to conduct the analytical and performance validation before a randomized control trial evaluating efficacy or safety or patient outcomes. Let me close with some core takeaways and point you to some practical resources. Best practice number 1, don't fear the black box. You don't need to be a programmer or a data science, person to do this work effectively. You just need to focus on things like inputs, the data inputs, what data is being used. Is it representative, and what are the known limitations? Also the outputs, what does the AI actually do for the participants and the scientific foundation? Has this tool been demonstrated? Baseline accuracy on that target population. Best practice number 2, identify the current stage, 3. Identify that current stage. That would be 3. But anyway, so that 3-stage framework is how you scale your oversight to actual risk. Stage 1, right, looks very different from stage 3. So don't apply that same level of scrutiny to both. And then we're going on to that intended use, which is item 2. Identify the intended use. That statement drives the entire regulatory and ethical analysis. If the protocol is vague about what the AI actually does, or even understates it, then you need to send it back so you can have it clarified better. And then best practice number 4, that last one, watch for data integrity and decommissioning. So the training and validation data must match the population that you're deploying the tool in or on, and the protocol must address what happens to the data and the models after the study ends. So the AI-HSR IRB review checklist, which walks through all 4 checkpoints in a structured form, is available for free through TechInHSR. You can scan this QR code on the slide or visit techinhsr.com. It's designed to be usable by any IRB reviewer, regardless of technical background. If your institution is working on building out its AI review capacity and you want to think through what that might look like, you can reach out to me directly. If you just want to talk about these things, also you can reach out to me as well. And with that, I think we can wrap up our webinar.